Today we're going to spend time talking about interval notation. We did use this a lot last year with domain and range, so this might be a repeat lesson for many of you. If we look at this table, here we're just going to discuss what intervals are and how we write them. So for the first section, this section here, it says all real numbers from A to B, including A and B. That's describing this number line. And it's saying that it's all real numbers from A to B. A being right here, B being right here. Because this is a closed interval, those are both two endpoints, we call this a finite interval. If we were to write this as an inequality, we would write this as A is less than or equal to X, which is less than or equal to B. That's telling us that X is any number in between A and B. Now, if we write this using interval notation, we would use square brackets, A, comma, B. Square bracket on both sides. So I'll explain the brackets in just a minute. For the next number line, we have something a little different here. Here we have an open circle at A, and then it appears to go on forever. So in the positive direction, this graph or that line goes on forever. The statement says all real numbers greater than A. Because this goes on forever, we would call this an infinite interval. And again, that's because it goes on forever right here. Indicates it keeps going. If we were to write this as an inequality, we would say that X, being all numbers, is greater than A. And the reason why we just use a greater than symbol is because it is an open circle at A, it is not closed. And using interval notation, we would use a round bracket or a parenthesis, A, comma, positive infinity. And this last number line says all real numbers less than or equal to A. You can see that we have a closed circle at B, but we can also see that it goes forever in the negative direction. So this is what I'm talking about right there. It's moving in the negative direction forever. Because this goes on and never has an end point, we would call this an infinite interval. Writing this as an inequality, we would write this as X is less than or equal to B. And using interval notation, we would use a parenthesis for negative infinity, comma, B with a square bracket. So this here is an example of, or three examples of interval notation, which is what we're working towards today. Let's talk about when you use square brackets or round brackets. So you use a square bracket which look like this, to indicate that the interval includes an endpoint. So includes would be a closed circle. Take a look at the first example we went over in the chart above. So if it includes an endpoint and you were to write it as an inequality, you would write it as greater than or equal to, less than or equal to. You use a parenthesis to indicate that an interval doesn't include an endpoint. As an inequality, that would just be greater than or just be less than. Okay, a couple of important notes. One of them being, for an interval that is unbounded at its positive end, you want to use the symbol for positive infinity. The other one stating that an interval unbounded at its negative end, you want to use the symbol for negative infinity. But in either case, whether you're using positive or negative infinity, you always pair these with parentheses. So positive and negative infinity always receive a parenthesis, not a square bracket. If I draw a quick number line, just note that negative infinity is always to your left or heading towards the most negative numbers you see, and positive infinity is always towards your right or heading in the same direction as your positive numbers. When you're writing interval notation, you always write the smallest number first. So for example, if you are writing an interval between, let's say, -5 and +10, you would write -5 first. -5 is the smallest number. And that's just an example. Okay, the first example set talks about finite intervals. So these are intervals that fall between endpoints. They might be closed or open endpoints, but they have an actual endpoint. So for the first one, we see a number line, and it appears that the values are between -3 and +2. At both of these numbers, we have closed circles. So closed circles represent square brackets. If we were to write this as an inequality, we would write this as -3 is less than or equal to x, which is less than or equal to 2. If we were to write this as an interval, we would write this as -3, smallest number first, comma 2. Use a square bracket with both of those because of those solid endpoints. For the second interval, we have a number line with the same values, but this time we have an open circle at -3, and we still have a closed circle at 2. This is going to indicate that we use a parenthesis with the open circle and a square bracket with the closed circle. Using an inequality, we would write this as -3 is less than, open circle indicates that it is not included, so just less than. -3 is less than x, which is less than or equal to 2. And in interval notation, we would use a parenthesis with -3, comma 2 with a square bracket. You can mix square brackets and parentheses. It's specific to the point, so make sure you pay attention to where the point is and how it is written. Also note that in both of these examples, the smallest number is first. For the second example, we're looking at infinite intervals. These would be intervals that continue in one direction, so they never have an endpoint. Or I should say one side of them doesn't have an endpoint. Looking at the first interval, we can see that it starts at -infinity or starts towards -infinity, approaches 2 with a solid endpoint. If I was to write this as an inequality, I would write this as x is less than or equal to 2. And as an interval, I would write it as negative infinity with a parenthesis, comma 2 with a square bracket. Infinity always receives a parenthesis, and then a number receives the correct bracket based on what's going on. In this case, we have a closed circle. Closed circle is a square bracket. The next example starts at positive 2 and heads towards positive infinity. Note that this is an open circle. Open circles receive parentheses. As an inequality, x is greater than 2. If we were to write this in interval notation, we would write it as 2 to positive infinity, both using parentheses. Make sure you get that right. Still the smallest number coming first. If you notice, I just underlined negative infinity. There's never a number that's smaller than negative infinity. Negative infinity will always be used as the first number if you are using it. Okay, unions. So if a set includes more than one interval, they are joined using the symbol or the union symbol. It looks like a U. This is a done example for you. So we have this number line, and we have the interval between -6 and -4, and another interval between -2 and 5. The first interval is between, like I said, -6 and 4. -6 receives a square bracket because of the closed dot. -4 receives an open bracket because of the open dot. The second interval is -2 and 5. -2 has a parenthesis because of the open dot. 5 has a square bracket because of the closed dot. When you take these two intervals and you write them together, you literally just write them together with the smallest numbers first, and you include a union in the middle. Let's look at the last example set, which is 4 examples using interval notation. Number 1 is a number line that appears to have multiple intervals. So I'm just going to make a quick note right here. I can see that my interval goes between -4. -4 will receive a square bracket. Looks like there's an open circle at -1. So we're going to use parentheses there. And a closed bracket at 3. So if I write this in interval notation, I'm going to have an interval between -4 and -1 with a round bracket, union, -1 to 3 with a square bracket. So just note, when you have an open circle, that means the number is not included. On this number line, we can have any number between -4 and -1, including -4, but not including -1. And we can have any number between -1 and 3, not including -1, but including 3. And smallest numbers come first. Number 2 appears to have 2 infinite intervals, one heading towards negative infinity, one heading towards positive infinity. This interval here heads from negative infinity to -4 with an open circle. We're going to write this as negative infinity to -4, both receiving round brackets. This next interval starts at +4 heads towards positive infinity. When we write this as an interval, make sure you use a union, and we write this as, using parentheses, 4 to positive infinity. All right, the next two examples are given to you in, or as inequalities, I should say. I do think that if you're a visual learner, it's definitely easier to see the interval notation if you use a number line. So I'm just going to quickly sketch a number line and graph my inequalities. So my inequality, or the first inequality, shows that it's between -2 and 6. -2 has a solid circle. 6 is going to receive an open circle, and the line goes in between them. So the line represents all values of x. So x is the set of numbers. It can include -2, but it cannot include 6. Our next interval says that x can be greater than 11, not greater than or equal to, just greater than. So open circle at 11 and make that head towards positive infinity. The only reason why I graph this is for anyone who wants to see it visually. Once you have this graphed, you should hopefully see that you can write this in interval notation as an interval between -2 and 6, a union, 11 to positive infinity. And the last example says that x can be greater than 8 or x is less than 3. So we're going to need a union on this one. Make sure when you do this, you notice that 3 is actually smaller than 8. So I gave you these two numbers in the wrong order if you were writing in interval notation. So be mindful, make sure you always have that smallest number first. If x is less than 3, we can write that as -infinity to 3, or x is greater than 8, so 8 to positive infinity. Remember, you can always sketch a number line. That might save you a minute if you're a visual learner, so use that as an extra tool when you are writing in interval notation. All right, please try to complete the on your own section by yourself. My answer key is posted on my website, so feel free to check that out for the answers on the on your own section.